Liftall, the world's largest manufacturer of slings for the material handling industry, presents Safety in Lifting. This presentation is designed to make you more familiar with the wide range of material handling slings available to help you lighten the load, and to highlight procedures that can improve safety awareness for sling applications. In short, to provide life-saving knowledge for field personnel. Slings can be divided into two basic categories: those made from synthetic materials and those made from steel. Synthetic slings are often used where protecting the load is a major concern. They are lightweight and easy to use, making them the first choice for many applications. Two types of synthetic slings are web slings and round slings. For web slings, several types of webbing are available to accommodate the varied needs of web sling users. Most sling webbing has interior yarns that offer reserve strength in case surface yarns have been damaged. Polyester and nylon are the two most common fibers used to make sling webbing. Nylon will stretch approximately 10% and polyester will stretch approximately 7% at rated capacity, both helping to dampen the effects of dynamic loading. If used in a chemical environment, contact the manufacturer for recommendations. Standard sling webbing is available in two strength ratings: 1,200 pounds per inch of width for standard duty, or 1,600 pounds per inch of width for heavy duty. 1,200-pound web is approximately 1/8 of an inch thick. 1,600-pound web is approximately 3/16 of an inch thick. Sling webbing is available with edge-protecting yarns to help reduce abrasion and cutting of the edge. Sling webbing is also available with abrasion-resistant yarns covering all surfaces. Unlike web slings, all of the load-bearing fibers in most round slings are enclosed and protected by a 2-ply independent cover. Round slings are made with either polyester or aramid core yarns. Aramid core slings have the lowest sling weight per capacity of all slings, making them especially useful for large capacity lifts. Industry standard colors for polyester round slings designate specific capacities. Steel slings are used for rugged loads or applications where elevated temperature, cutting, and/or abrasion are a problem. They are typically used in conditions that could be abusive to synthetic slings. The three basic types of steel slings are chain, wire mesh, and wire rope. Wire rope slings are a standard in the construction industry. Made from high-strength steel wire rope, they are available in many sizes, capacities, and configurations to meet a variety of lifting situations. The most commonly used rope is a 6x19 construction with an independent wire rope core. This rope offers good resistance to abrasion and flexibility sufficient for most applications. For greater flexibility, use ropes having a greater number of wires, such as a 6x37 class rope. Multi-part cabled or braided wire rope slings can offer an even greater degree of flexibility. For added flexibility and corrosion resistance, cable-laid wire rope slings or multi-part slings made from galvanized or stainless steel wire rope make a great choice. Chain slings and attachments are made from alloy steel, engineered for strength and durability. They are used for the most rugged applications, including high-temperature environments such as foundries and steel mills. Alloy steel chains are the only chains recommended for lifting purposes. Two grades of chain commonly used for slings are grade 80 and grade 100. Grade 80 is the industry standard and most widely used. Grade 100 is approximately 25% stronger for the same chain diameters, allowing a lighter sling to be used in certain situations. Wire mesh slings are made from high-tensile steel wire, wound and fitted together to form a flexible, smooth, flat-bearing surface. Mesh slings offer good cut resistance while protecting loads from damage and are commonly used with lifting beams to handle steel bars and bundled loads. Lift-all slings are manufactured to the highest standards and tested for reliability, performance, and user safety. As good as these products are, it's up to you to select the right sling for each job and to use safe lifting practices. If you don't, property damage, personal injury, or even death could result. There are many factors that must be taken into account when planning a safe lift. Failure to understand and apply the following practices may result in personal injury or death. The following guidelines meet OSHA and ASME B30.9 requirements. Never load slings in excess of their rated capacity. An important step in planning a safe lift is examining the load. You must consider the weight of the load, its structural stability, and center of gravity. If you do not already know the weight of the load, check for identification plates, shipping papers, manufacturer's catalogs, or contact the manufacturer. If you are unable to get a weight using these methods, you may have to estimate the load weight based on volume and standard material weights. Consult your supervisor if you are unfamiliar with these calculations. Another consideration involving the weight of the load is the center of gravity of the load. If only one crane hook is used to lift the load, it must be positioned over the load's center of gravity. Failure to do so will result in the load shifting and possible loss of load control. Whenever possible, fluids should be drained from the load to avoid shifting of the center of gravity during movement. Structural stability must be examined to avoid damage to or loss of the load. Some loads have designated pick points that are to be used for lifting purposes. If these are not available, be sure that the areas in contact with the sling will withstand the stress of the lift. Also remove or secure any loose parts. Check the sling tag for important information such as rated capacities, length, material, and manufacturer. Read the warnings on the sling tag and review the instruction sheet that accompanies a new sling for specific inspection and operating practices information. An essential step prior to selecting a sling is determining how the load will be rigged. You must take into account the type of hitch, vertical, choker, or basket, and the number of slings to be used. If lifting smooth cylinders or loose bundles, a double wrap choker or basket hitch may improve load control. This will give you 360-degree sling contact with the load and help prevent the load from slipping out. When using slings at any angle other than 90 degrees from horizontal, the tension on the slings increases. To illustrate, we have installed dynamometers in line with the slings being used to lift this load. The total weight being lifted in this example is 1,000 pounds. At exactly 90 degrees, the tension on each of the two legs would be 500 pounds. As the angle is decreased, the tension on the slings increases. What was 500 pounds at 90 degrees becomes 578 pounds as the angle reaches 60 degrees. 707 pounds as the angle reaches 45 degrees. And 1,000 pounds on each sling when the angle becomes 30 degrees. In essence, our 1,000-pound load weight, as seen by these slings, has doubled with this decreasing angle. For this reason, particular attention must be paid to sling capacities and load weights when using slings at angles of less than 90 degrees. Slings should not be used at angles of less than 30 degrees. Charts are available from Liftall for calculating this critical effect of angle on sling's capacity. When in doubt, use the sling at only half of its rated capacity for the hitch being used. When multiple slings or sling legs are used, the legs may not be loaded equally. A qualified person should review the lift to avoid the overloading of any leg. After examining the load and determining the sling's rated capacity, you must inspect the area where the lift will be done. It is important that you identify the conditions and hazards of the work area and how they will be handled. Also be aware of how much headroom you have to lift the load. Check your hook travel and make sure you have a clear path. Locate electrical power lines, steam pipes, sprinkler lines, overhead conveyors, and air lines. If necessary, measure the ceiling clearances and doorways. Know in advance what lies in your lifting path. Look for movable or projecting objects, slippery surfaces, obstacles you could trip over, and dips or grades along the traveling surface. Additionally, you must contain or control pedestrian traffic in and around the load's travel path. Secure your work area using approved methods, such as rope, sawhorses, warning lights, and tape. You must never lift a load over people. Personnel should stand clear of the suspended load. Tag lines can aid in guiding and controlling the load. When choosing a sling that is going to be used in elevated temperatures, remember that each type of sling has a different temperature limit it can withstand. Web slings and Tuflex round slings must not be used in temperatures that exceed 200 degrees Fahrenheit. Keyflex round slings with their aramid fibers may be used in temperatures up to 350 degrees Fahrenheit. Wire rope slings with a fiber core must be removed from service if used in temperatures over 180 degrees Fahrenheit. Wire rope slings with a wire rope core must be removed from service when used in temperatures that exceed 400 degrees Fahrenheit. Chain sling capacities must be reduced when used at temperatures of 400 degrees Fahrenheit or more. Permanent capacity reduction begins at 500 degrees Fahrenheit for grade 100 chain and at 600 degrees Fahrenheit for grade 80 chain. Never use chain slings in excess of 1000 degrees Fahrenheit. Wire mesh slings can be used in temperatures up to 550 degrees Fahrenheit. Check for chemical exposure before using slings. Each sling reacts differently to chemicals or chemical environments. Sling strength can radically decrease if used in or even near the wrong chemicals. Check manufacturer's guidelines for chemical compatibility. Loads must be rigged to prevent movement of the sling along a load edge. Tremendous pressure exists at the bearing points where slings contact the load. Should a synthetic sling slide along a load edge while under tension, there is a good chance that the sling will be severed and drop the load. Reduce movement by using sling angles of 60 degrees or greater and by using double wrap choker or basket hitches when practical. Always protect synthetic slings from being cut or damaged by corners, edges, or protrusions. Be sure to use wear pads to help protect the sling and prevent friction or cutting damage to the sling body. These protectors must fully resist the pressure created between a sling and load edges. Steel slings are less easily damaged by cutting and abrasion than synthetic slings, but pads may still be appropriate to protect the sling and/or load from damage. There are many pad styles and materials available to accommodate most applications. Sewn-on pads for web slings might be appropriate when repetitive lifts wear specific areas of the sling. For more versatile use, sliding sleeves offer protection where needed at the time. Quick sleeve style pads can be easily applied to and positioned on the sling. These pads are appropriate for web slings, round slings, chain and wire rope slings. There are many materials that can be used for wear pads. Some of the more popular are synthetic felt, sling webbing, and leather. If being used for the first time, the ability of a wear pad or other protective device to perform effectively needs to be verified. To accomplish this, raise the load only until it is just barely suspended, then lower the load and inspect the sling and protection materials. If damage is evident, change the type of protector, sling, or hitch and perform the test again. Repeat the process until the sling and protector have not been damaged. OSHA regulations for slings are available online at www.osha.gov. Regulation 1910.184. Additional up-to-date guidelines can be found in ASME B30.9, the Web Sling and Tie Down Association standards, and the Liftall catalog, website, and instruction sheets that accompany each sling. The usable life of a sling can be extended by following proper care and operating procedures. All slings should be stored in a cool, dry area. Web slings should be stored away from direct sunlight. Extensive exposure to ultraviolet light can damage web slings, decreasing their strength. When using slings, never rest loads on top of them and do not drag them on the ground. Do not point load the hook. Make sure the sling, attachment, and load does not snag on anything in your lifting path. Do not twist, kink, or knot slings. Equally important to the proper use of slings is guarding against personal injury. Always keep your hands clear of slings and loads and stand away from suspended loads. Also, never ride the sling or the load. Liftall operating procedures require that you always inspect slings before each use. OSHA states that the sling and all fastening and attachments shall be inspected for damage or defects by a competent person designated by the employer. Damaged or defective slings shall be immediately removed from service. In addition to these requirements, OSHA and ASME specify that chain slings receive a thorough inspection at least once per year, and that the employer maintain a record of the most recent inspection. As you recall from the first part of the program, slings can be divided into two basic categories, those made from synthetic materials and those made from steel. There are two varieties of synthetic slings, web slings and round slings. These slings should be removed from service at once when you find cuts, holes, knots, tears, snags, abrasions, damaged fittings, melting or chemical damage, worn or broken stitching, or missing or illegible tags. If any of these problems occur with your synthetic slings, they should be removed from service immediately. An additional indication that a synthetic web sling has been damaged is exposure of the red core yarns. A sling in this condition should be removed from service immediately. Toughlex round slings should be replaced when cover damage is sufficient to expose the load-bearing inner yarns. The three basic types of steel slings are chain, wire mesh, and wire rope. Per OSHA and/or ASME instructions, wire rope slings with the following conditions must be removed from service immediately: kinking, crushing, bird caging, wear, corrosion, damaged sleeves or end fittings, missing or illegible identification, or heat damage. Wire rope slings damaged by heat can be difficult to recognize. A good indication of damage is absence of lubrication or discoloration. Another common cause for wire rope sling rejection is broken wires. 10 broken wires in one rope lay, or 5 broken wires in one strand in one rope lay, is cause for rejection. Chain slings must be removed from service immediately when they have one of these problems: wear, nick or gouges, cracks or breaks, elongation, twisted or bent links, weld spatter, lack of component flexibility, missing or illegible identification, unauthorized or makeshift repairs, or excessive heat damage resulting in severe discoloration. See manufacturer's recommendations for specific rejection criteria. The following conditions on wire mesh slings indicate they must be removed from service immediately: broken welds or wires, abrasion, corrosion or heat damage, missing or illegible identification, reduced flexibility, or field repairs. The safety inspection must include end fittings and attachments in both the synthetic and steel sling categories. According to OSHA regulations, end fittings and attachments must be replaced when they show any of these problems: cracks, distortion, or wear. If a hook latch is present, it must be in good working condition, or it could prevent the sling from working properly. Slings and their end fittings that do not pass safety inspections should either be destroyed or sent back to the manufacturer for further evaluation and possible repair. Never attempt to do the repairs yourself. Damaged slings and their fittings should never be used in any lifting situation. Web slings, Toughlex round slings, and wire rope slings cannot be repaired. However, undamaged end fittings and attachments can be returned to the manufacturer for possible reuse. Chain and wire mesh slings can be repaired by the manufacturer. We recommend that any reused parts or end fittings be proof tested and certified. If you follow the guidelines in this presentation, not only will your lifts be more effective, but much safer, and the life you save may be your own. Safety in Lifting is a special presentation from Liftall, brought to you in the interest of worker safety and the efficient handling of materials. For additional information on products and safety procedures, contact Liftall by phone at 800-909-1964 or visit our website at www.liftall.com.